Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically today we are going to discuss about that what is a bounded semaphore, right? In the previous video we had discussed about the semaphores, right? We had seen that what are semaphores and what are they actually used for. Now today we have another thing and that is a bounded semaphore. We are going to discuss that what do we actually mean from bounded semaphore and what it is used for, and after that we are going to see a program in which we will be using out the bounded semaphore, right? So I'll be starting here for the bounded semaphore, but for before that once I just want to discuss about the definition for the semaphore. Once I just want to discuss that thing which we have seen in the previous video, right? We had seen about the semaphores that semaphores can be used to limit the access to the shared resources with limited capacity. So this is a basically advanced part of the synchronization. Right, this is about the semaphores. That semaphores can be used to limit the access to the shared resources with limited capacity. It is an advanced part of the synchronization. This was about the semaphores, right? Now let's move toward the bounded semaphore. And a bounded semaphore checks to make sure its current value does not exceed its initial value. So basically in bounded semaphore what happens that it basically checks to make sure that the current value which it is having actually that does not actually exceed the initial value. Okay, this is what the bounded semaphore actually does. Okay, and basically if that value is raised, if the value exceeds the initial value, then basically we get a value error as an output, right? This is what actually the bounded semaphore actually does, right? That boundary semaphore checks to make sure its current value does not exceed its initial value. If it does, value error is raised. Now I would be writing out a program for the bounded semaphore, and let's see basically that how we can write out the use and basically use out the bounded semaphore. Okay, so the very first thing, as we know that this comes under the topic that is actually threads, right? Here we'll be making a thread, and from that only we'll be using out the bounded semaphore. So for the very first thing that I'll be doing is that I'll be importing out the threading module here, right? So basically in the previous Python, basically not in the Python 3, but in the previous Python, we simply used to import threads. But even as we are using Python 3 now, so in that basically we need to import the threading module only. If we're just gonna import the threads, so that will be resulting you the error, right? So in that case, we simply import the threading module only. Other than that, I'll be importing here the time module. So I have to writing import and then the time. Okay, I'll be importing out the time module as well here. Fine. So I'll be using these two modules throughout my program. What I would just do is that I'll be take a variable. Let's say to that variable I have given out a value. Let's say that is 2. Let's say. Okay, let's say 2 is a value which I have given out to this variable that I have made, and that is var is equal to 2. Right, I would come on to the new line. Now, basically in this particular new line, I'll be taking out a variable, let's say that is A. And I'll be using out my bounded semaphore. Okay, I'll be writing here threading dot, and I'll be writing here bounded, and here I'll be using semaphore like this. Okay, instead of this 2, let me take here as 3. Okay, so A is equal to, with the help of my threading module, I have used here my bounded semaphore, which basically allows us, what it does actually, it checks to make sure that the current value does not exceed its initial value. This is the work what bounded semaphore actually does, right? So for that as well, I've just used here my bounded semaphore. I'll put out a bracket, and we have a parameter here that is value. Okay, so into that parameter basically I'll be passing here as var. So var is my variable in which I have stored a value that is 3. So now basically this bounded semaphore actually check that the current value which we are having, that is 3, that does not exceeds the initial value, and if it actually does, then a type of value error is actually raised, right? This is what it will actually do. Come on to the new line. Here this is done, right? I'll be defining a function. Let's say that function is 1. Put out the brackets. Now I would be using out my acquire method here, right? So that I'll be using with the help of the variable which I have made, and that is A. Okay, so A dot acquire, like this I'll be writing out here. Fine. Okay, so I just use out my acquire method here. After this, I'll be using out one of the print statements, right? I'll be using out one of the print statements actually here. And into that print statement, I'll be first of all using out my threading module. So here goes my threading module, threading dot. Now we have a function that is current underscore thread. Okay, we have this function already, current underscore thread, right? I'll be putting out a name here, like bracket here, and after that I'll be putting out the name. Okay, now let me just first come down. Fine, threading is my module. Okay, this current underscore thread is my function, and from that I'm just trying to find out the name from here. Okay, I'll be putting out a plus sign, and into that basically what I'll be just putting is that okay, I'll be writing acquire the resource. Okay, okay, let's say acquire the value. Let's say this is a sentence that I would be writing here after this. So as well, I'm just using this acquire so that I just can understand that which is the value, which is which is the print statement that is run after the acquire, and which is the print value that is actually run after the remove function. Right? This is the way. That's why I am just writing this out here. Fine, so in the bracket, here it is threading module, my current underscore thread function dot name, and with the help of the concatenate function, concatenate, that's plus, I use the acquire the value. Right, now my acquire function actually has been used here. Now next thing comes that I'll be using some time dot sleep. Okay, and let's say my time dot sleep is 0.5. So after every 0.5 seconds, I'll be getting out my output here, whatever is required for this, basically for this thing. Okay, that I'll be getting out here. So time dot sleep, and it is 0.5. Right, now what next I'll be doing here is that I'll be using a dot release. Okay, first of all I used out my acquire function. Now I'll be using out my release function. Right, a dot release. And in the next line I'll be using out my print statement, and inside that I'll be writing again the threading module. Put a dot. After that, I'll be using the current underscore thread, current thread function, and then I would be putting out a dot here, then using the name. Right, after that, I'll be putting out a plus sign, and here I'll be writing release release the value. This is the statement which actually I wanted to be printed, so I have just written that thing here, right? The release the value. So inside my print statement, I have, just let me show you that what I have done. Inside my print statement, I have taken out my threading module, and there after that, I've just used out a function that is current underscore thread and then name. Right, and after that I put out a plus sign and used release the value function. Right, this is what I have done till now. Fine. Come outside the function. Now here I'll be defining a variable that is name, so that will actually store a empty list. Right. Now, I'll be applying a for loop, that for I. Okay, I'll be applying a for loop here for I in range. Okay, for I in range, and let's say my range is 1, 4. Okay, let's say this is my range. Let it be 1, 5. Right, so for I in range, I is basically one of the variable which I have taken, and I put out a range that is 1, 5. Okay, so for I in range 1, 5, I'll be making another variable that is a underscore name. Okay, I'll be making another variable a underscore name, and into that, with the help of the threading module, I would be now making out some several threads. Right, threading dot T would be capital for my thread. Okay, into the bracket, I'll be writing what should be the name. So my name would be, let me give some space here, name would be thread. Okay, okay, just let me calm down. Fine, name would be thread here. Okay, what would be the addition? So plus I just want the string of I, str of I. So basically what I just want that whatever my index is actually going on, that particular name should come. It should come like thread 1, thread 2, thread 3, something like that it should come. Right, in that case I'm just writing plus stri. And what is my target actually? So my target is my function. Okay, let me write correct target. And my target is my function that is actually 1. Name for my function is actually 1. Right, that I have written out here. And at last, I'll be writing here a underscore name dot start. So here this start will basically help to start out my threads actually. Okay, let me quickly give you a revision what I have done, then we'll be seeing the output. So we have imported out the threading module and the time module here. After that, I have taken a variable that is var, and into that I had stored a value that is 3. let's say, okay. Then I had taken another variable that is a, and into that with the help of my threading module I have used the bounded semaphore function, and into the bracket I have given out a value that is 1. So my basically my current value is actually 3, and this should not exceed my initial value. If it exceeds basically, so then what does then the value error is actually raised. This was what the bounded semaphore does, right? It checks to make sure its current value doesn't exceed its initial value, right? After that, I have defined out a function that is 1, and then I use the acquire function, and into the print statement I used out my threading module and use that with the help of the current underscore thread function dot name, right? And I just use a statement that is acquire the method. Same thing I did here for the sleep. I just wrote out a sleep time that I want my output to come in this much interval of time. See, 0.5 inside the sleep function we always give the value in the seconds only, okay. After the use of acquire method, I used out my release function here, right? That is print threading dot current thread name plus release, right? And inside a print statement, I just use that thing. After that, I have defined a list, okay? Blank list, that is the name is names. After that, I applied a for loop that for I in range 1, 5, okay? A underscore name is a variable which I defined, and here I defined my threads with the help of the threading module. Here is my thread. What should be the name into that? Name should be thread plus I have written str of I. Str of I, what it will do actually? It will take one element from this I. Okay, it will take one element from here and it will write here str of I. And simply I wrote target is equal to 1. That is, I just called out my function here, and at last I simply started my thread. Right, I would just run out this thing here. So here we go with the output that is coming, that thread 1 acquire the value, thread 2 acquire the value, thread 3 acquire the value. After that, thread 3 is actually released, thread 4 has acquired the value, thread 2 released, thread 1 released the value, and then at last thread 4 released the value. First of all, all the 4 threads, because I have taken out the range that is 1, 5. So it will go 1, 2, 3 and 4, right? So it basically all my 4 threads have first of all acquired the value, and after that all of the 4 threads have actually released out the value, right? And this is how we use out this bounded semaphore, right? So I hope that basically you have got a fair and a clear idea regarding that what is actually bounded semaphore and how we just use that thing into the programming, right? So this is all for this video. Till then, thank you and take care.